Conditional statements. These are your notes. Your essential question: what is a converse, inverse, contrapositive, and biconditional? So let's get started first by doing some vocabulary. First, we have logic. So an example of logic is when you use true or false on a test. So true and false basically sum up what logic is. A statement is a sentence that's either true or false. And of course, T is for true, F is for false. Truth value is basically whether something is true or false. Negation is when you make a statement have the opposite meaning as well as the opposite truth value, and this is what it looks like. This is how you read it. Conditional statement. Okay, so a conditional statement is different than a regular statement. So, right, a regular statement is just any sentence that can be true or false. A conditional statement also can be true or false, but it's specifically written in if-then form. For example, we have the statement, a person living in Austin lives in Texas. So this is our statement right there. So we have two parts of this statement. A person living in Austin lives in Texas. That's the second part. Now, if we change it to a conditional statement, again, we have a person living in Austin, but now it says if a person lives in Austin, then they live in Texas. So again, we have the if and we have then. All right, so following that, we see that we have the part that comes after the word if, and that is the hypothesis. We call that the hypothesis, and it comes right after the word if. And we have the conclusion, which comes after then. Okay, related conditionals are just other statements that are related to conditional statements. All right, now conditional statements are formed in the if-then format, but this is the, I guess, symbolic way to write it. P is the hypothesis, so that's the part that comes after the word if. Okay, I put that in yellow. And then Q represents the conclusion, and that's what comes after the word then. So just like before, if a person lives in Austin, then they live in Texas. The first part is the hypothesis, the last part is the conclusion. So that again is a regular schmegular conditional statement. Now converse happens when you swap them out. So now the hypothesis is gonna go first. So you see over here in the example, if a person lives in Texas. So now we're putting the Texas part first and the Austin part second. So we just switched them. That's what a converse is. Now an inverse is going to use negation. It looks like the conditional statement. It starts with P, but now it has the negation of P, which is not. Remember, we just talked about that on the first page. So if a person does not live in Austin, that's what the squiggle means. The squiggle means not. If a person does not live in Austin, then they do not live in Texas. Okay, so these two are in the same order. The hypothesis is first, the conclusion is second, but they are both not. Now, something interesting you need to know about converse and inverse. If you see over here on the left side of the screen, converse and inverse are related, okay? They have the same truth value. They have the same truth value. So basically, if the inverse is true, the converse is automatically true. So let's take a look. If a person lives in Texas, then they live in Austin. Well, that's sometimes true, but it's not always true. You can live in Houston, right? So this is false. Now, if converse is false, inverse is also false. So let's read the inverse. If a person does not live in Austin, then they do not live in Texas. Well, they could live in Houston. Again, it's false. That's always going to be the case. If the inverse is false, the converse is false. If the, vice versa. If one is true, then the other is true. So that's the relationship between converse and inverse. All right, let's move down to contrapositive. Contrapositive. So contrapositive is when you swap the hypothesis and conclusion and you negate them both. So we switch the Q. Q is first, but it's also not. So if a person does not live in Texas, and then now this hypothesis is last, they do not live in Austin. So we switch P and Q and we put not for both of them. So contrapositive does both things. It swaps it and it also makes it both not or opposite. All right, now let's talk about the relationship between contrapositive and conditional. So as you can see over here on the left side, there's a relationship between contrapositive and conditional. It's the same thing. If one is true, the other is true. If one is false, the other is false. Let's take a look. If a person lives in Austin, then they live in Texas. That is true. However, if a person does not live in Texas, then they do not live in Austin. That's also true. And again, we're doing this assuming that Austin, Texas is the only Austin in the world. Okay. So yes, if one is true, then they're both true. If one is false, then they're both false. All right, now we're going to talk about biconditional. So a biconditional statement, okay, happens when the conditional is true and the converse is true. So the conditional is true and the converse have to be true. If both of those are true, then it is biconditional, and the way that we write it is by using if and only if. And if and only if is represented with IF. That's how we write if and only if in shorthand. So we have our hypothesis, we have our conclusion, but instead of an arrow pointing to the right, we have an arrow pointing in both directions because, again, this is biconditional. All right, so a person lives in Austin. If and only if, and don't forget that's IFF for short. So if you see me write IFF, no, I did not misspell the word if. That means if and only if. They live in Texas. Okay. Now, since both the inverse and converse are false, the biconditional technically doesn't exist. So don't forget, the conditional and the converse both have to be true. But look, the conditional is true, but the converse is false. So this biconditional technically does not exist. I wrote it down to give you an example, but technically it does not exist because both the conditional and the converse do not prove true. All right, example 2. So our conditional statement is, there we go. If an angle measures less than 90, then it is acute. So I've labeled it. This is my Q, my P rather, and this is my Q. Bloop. Okay, so don't forget for converse, let me just switch that real quick. Okay, so for converse, you're gonna switch Q and P. For inverse, it's not P, not Q. And then for contrapositive, you switch them and you make it not. So not Q, not P. And then biconditional is P if and only if Q. So those are what you need to remember. So I'm going to go through and mark all of the P statements or the hypotheses. So if an angle measures less than 90. So let's see. Got less than 90 right here because don't forget P comes second. Okay. And Q comes first, so those two switch. Now for inverse, we do start with P, but they both say not. So we have, if an angle does not measure less than 90, right, then it's not acute. Not acute. Okay? Not acute. Contrapositive, we switch them and we make them both opposite. So if an angle is not acute, then it does not measure less than 90. So again, for both of these, we have not. And they also switched. And I did that backwards, so sorry. Okay, if an angle is not acute should be my conclusion, right? Because that was what the original one said. It does not measure less than 90. Sorry about that mistake. Just fix it real quick on yours. All right, and then for the biconditional, an angle measures 90 degrees if and only if it is acute. Okay? And of course, you could also write it backwards. That's why the arrow goes both directions, because it's true in either direction. All right, so let's see. All statements must be true for the biconditional to exist. So let's see if that is the case. So if an angle is acute, then it measures less than 90 degrees. That is true. If an angle does not measure less than 90 degrees, then it is not acute. That's also true. If an angle is not, well, let's do the conditional. Let's go back up to the top. If an angle measures less than 90 degrees, then it is acute. That is false, because if an angle measures 0 degrees, it is not acute. Okay? So that is false. So that's your counterexample. Contrapositive, if an angle is not acute, then it does not measure less than 90 degrees. Well, since the conditional was false, the contrapositive is also false. So, since the conditional was false, but the converse was true, that means, since they're both not true, the biconditional technically does not exist. Even though I wrote it down just to give you guys an example of what it would look like, it does not exist because they both have to be true. And that's it.